There's a few more seats up here if anyone wants to come get involved in this tonight. You know, I see some people back there. Get involved. I don't bite hard. Come on up, guys. Oh, don't run into Joe, though. He's a dangerous man. He's going to wine now. Welcome all to the Jersey City Tech Meetup in March. Give yourself a round of applause for being here. Thank you all for coming. Whose first time is this at a Jersey City Tech Meetup? Oh, nice. Always great to see new people. Thank you all for joining us. I see a lot of faces I recognize who's been here before. Don't be shy. There, I know you are. Thanks for coming back. Everyone give yourself a round of applause for the speakers, for PicoTurbine, Mike, for everyone hooking us up. Just thank you everyone for making this all possible. Kind of generally like to kick off the night with just giving people a few seconds to, you know, if you have an event or a company or something you want to promote or share with the group, you know, feel free to raise your hand and you can share whatever you want with the community. There you go.
Hi, my name is G.I. Jack from DEF CON.
Speak up a little bit.
Hi, my name is G.I. Jack. I'm from DEF CON 201, Jersey City, New Jersey. We're a local hacker group for, you know, representing northeastern New Jersey. We hold meetings which are open to everybody. Third Friday of every month in Journal Square in Jersey City. Journal Square is right next to Journal Square. It's that big, goofy-looking building that just opened out of that. So this Friday, it's the third Friday of the month. We will be there. We would, you know, you are all welcome to attend. You got a meetup page?
Thank you.
Yes, we do. We do have a meetup page.
And, yep, what's up, man?
Yeah, hi everyone, my name is Jimmy Zoe. You might have seen me waving my hands around furiously out there. I am an intellectual property attorney in Hoboken. I used to be a patent litigator and now I do a little bit of prosecution. I do trademark applications, trademark litigation, and if you guys have any intellectual property needs or if you just want to, you know, talk patents sometime, give me a call.
Thank you.
Hello, my name is Ty Buchantrowitz, and I'm the data scientist for the City of Jersey City, working inside the Department of Innovation. And as you may be aware, data science is a growing, very, well, it's a very baby practice in Jersey City. We're like literally starting out at the very basic level. So I am actively looking for volunteers and for suggestions and insight and help and assistance because it can't be built alone. Yeah. So, and the things that we're doing right now are going to affect the city of Jersey City and all of our lives in the future in the city for possibly the next 20 years. So help me out. So you can find, just hit me up, like, I'll be here for a while and I'll pass out cards. Otherwise, you can find me at tkantrowitz@jcnj.org. And none of you will be able to spell that, don't even front. Afterwards.
Thank you. What's up, man?
What's going on, everybody? My name is Martin. I'm a content producer. I do animation, design, visual effects, motion graphics, kind of across the board. I actually just got into 3D printing, so I do all types of things and create. I dabble in marketing, so anything I create is kind of based on trying to figure out how to brand.
Yeah, if you want to kind of start over, that's totally cool. I know there's a...
Hey, you guys.
Yeah, my name is Martin. I do a lot of social content, and I create cool ways to market.
So where can they find you? Online?
Poor Martin. I have cards.
So go talk to him.
And I started a studio, a digital studio, so
perfect.
I have cards.
Thank you, man.
Hey, my name is Jason Thomas. I own the Grassroots Collaboration Group, which is a startup incubator entirely focused on emerging technology in the cannabis industry as well. We are in the process of nailing down some physical space in New Jersey City or Hoboken. and we're going to be operational by June or July. So if any, I saw you. Don't worry, we made eye contact. But yeah, we are looking to bring on collaboration partners, people who want to mentor, people who want to coach, people who really like helping people get their ideas out, and really have that, best interest of the person who has the idea at heart. So we want to help people who've been impacted by social justice in the cannabis industry. We want to help people really get a foothold into the market. And from a technology standpoint, there's just a ton of opportunity and a ton of overlap between those two industries to not really pay attention to it right now. So we want to talk afterwards on that.
Perfect, thank you. Miles, Manny, don't you guys do some cool stuff? Share with the group?
Yeah. I was actually going to first.
And then we'll jump in.
What's up, guys? My name is Miles. I currently work with Guru Branding. We actually are not taking any more clients because, bandwidth-wise, we're not taking more personal branding clients, but we work in corporate and personal brands when it comes to startups and more distinguished companies. So when it comes to social media marketing, digital marketing, and agencies in that realm. So if you ever need a slight push when it comes to getting your name out there and stuff like that, we're definitely working with that. So definitely welcome to answering any questions, giving any comments, tips, anything like that. Please ask me. I love to talk about it, and definitely love to work with you guys. So
thanks. Give everyone a round of applause for sharing. Before we dive into the night, just a quick two quick announcements I'd like to make. Thank you to some of our sponsors. We're actually working with Ansel Law, and they are our legal sponsor, and they have a deal for the Jersey City tech community. So they have a deal for you if you go through me and our group that they do legal services for $200 a month for a package of legal services for you and your business. While there's normally an hourly fee, they have a special for the community. So if you're interested in that, come talk to us. Thank you PicoTurbine, obviously, for having us and for hosting. This is a great space, and we're all happy to be here. Thank you, Joe, for always hooking it up with the great content and social media marketing. So anything marketing or social media, branding, design, he's your guy. One more. And I would like to just, one more announcement before we dive into it. April 16th, we have a very important meetup. This is our Green Rush version 2. So last year, the biggest Jersey City tech meetup we had was revolved around cannabis, which turned out to be a really amazing, insightful experience for everyone. So this year, we want to take it, make it bigger and better, and get more people involved. So if you are trying to be a volunteer or anything, or sponsor, anything along those lines, vendor, come talk to me. I'd be happy to work with you. And for anyone who signs up for an email newsletter until Friday, 50% off tickets because you guys are loyal and awesome. You always come out. So shoot you an email with some details to get real cheap tickets, and it's going to be an amazing night. So mark the date.
I forgot I have something else I need to push.
Yeah, what?
One more thing I wanted to push, if I may.
That's okay. As long as you tell everyone they should come April 16th.
Hey, yo, come April 16th. Do it. So March 20th, I think it's like next weekend or the weekend after that, I can't tell time, is the Maker Faire at Jersey City Liberty Science Center. So I want to remind everybody that it might be still available to, if you want to have a booth or a table, you can also ping me and I can hook you up for that. But otherwise, just come out for it. We did it last year and it was awesome. And it's going to be great this year too. So thank you.
Great, thank you. All right, now what we're all here for. 3D printing special. We have a lot of awesome speakers tonight that are going to be talking about 3D printing and how it applies to different industries and applications throughout tech, art, environmental studies, and different things along those lines. So without further ado, I would like to pass the torch to Mike, who is the founder and CEO of PicoTurbine, and he's going to kind of set the pace for the night and kind of show you a little bit about what he does and how he incorporates it into this space with all this cool equipment you see. He's going to give us a little background on that. So everyone give it up for Mike.
Thanks, Ben. Appreciate it. Well, welcome to our space. First and foremost, I want to thank my team for supporting this event tonight, and then JC Tech Meetups for partnering with us. And I also want to thank all of you for making me feel that I made a right choice on the beard, because it's gone. So that's a fantastic feeling when you do something right, right?
Yes.
All right. So getting into it. So I, talked with Ben about this event. It's something I wanted to do for quite a while. We've been in this space for about 6 years now. So you can kind of look around the room and kind of see a little bit about what we do. Some of our, what I'll call medium printers over there. That is a medium printer. We actually have a bigger printer at our other facility, which is now in Kearney Point, where we're actually going to be relocating, unfortunately, from this space to that, to kind of micro-focus on what we're doing. But we'll be having some more meetups on that stuff, but I wanted to let you guys know that. So we're kind of actually having this party, and Saturday we're having one for the kids. That's kind of our closing these doors, but we do everything virtual and we focus in a different way. But I'll get into the details of that in the later part of my presentation here. If you look around the room on what we do, you'll see even a piano replicated in 3D printed format. You'll see a chair that somebody's sitting on. You'll see a lamp over there. A stool that unfortunately failed 80% of the way through, but it's still pretty damn cool.
This is cool, right?
It's a cool stool.
That chair?
Yeah.
That chair's awesome.
It will hold the weight of, no. No, that chair actually was not made in here. That was made in Italy.
Cool.
On the big printer you guys can see in that picture back there, there's 3 different ones. So we actually have all the rights to North America for that company from Italy. We're going to be making them here. It's pretty damn cool. That machine right there, 6 months to 12 months, we'll be making it. Right in Jersey City on the other side in our warehouse manufacturer.
You mean you have the rights to manufacture the machine?
We are partnered with them, joint venture. Over time, we'll be manufacturing the printers in the United States. Yeah, it's a big deal. Since 2015, we've been working with them.
How long would it take to make a chair?
Make a chair. That chair takes, depending on what you want, 6 to 8 hours, right?
Something along those
Yeah.
lines.
Depending on the machine and then what you want out of it, but anywhere from 6 hours actually could be as much as 16 hours if you really want that fine detail, right? To kind of give you that, there is definitely a spread on, depending on what you want in the end as your result. Behind you, Mr. Patent Attorney there, that right there is basically, before I get into my presentation, that is how we got into it. Right there, you see that wind turbine? That's how we got into it. That's a manufactured wind turbine overseas, went through that whole process, but to the left of it is 3D printed. That is the first turbine and product that we ever 3D printed in order to understand what 3D printing can do. As a small business, you'll see in my last slide, as a small business on a very, small budget, you got to be creative in how you create things, right? So, what tool is better than 3D printing? I honestly bought a MakerBot. I wouldn't do it again, but I'll say it out loud. But down in their downtown location, in their storefront that they had in the village, and I bought that, brought it to my office, and made that on there with my engineer. And that's how I understood there was something more to 3D printing, and also understanding how you can go through the product development process in a different way, versus going over to overseas, spending all the money and all the mistakes that you could potentially make as well, but getting it to market also faster. And that's what you'll see in my presentation, because I'm going to go over each of the different industries that we actually participate in, and some of them will be covered by speakers tonight, so I won't go into the detail of that, but it gives you kind of an idea. But to focus on that back there, on that top of that dresser, we have the wind turbines. Next to it, you'll see what the vertical base of our other turbine, and next to it, you'll see a robot. That actually was created by a relative of mine. To the right was actually there first, so that's our old turbine that we had. So the robot, the actual one that looks like it was manufactured, was actually done in reverse. That was done first, but my relative working with me realized it was cost prohibitive. It would have cost him 6 figures to actually get the mold and everything made. Instead, he actually now sells to the education market, the one Eugene's holding right now in red, 3D printed robots. Instead. Cost to start, a couple printers, a couple $1,000. Makes more sense for a small business to get going, right? So now that I kind of have the backstory, so I've been in business since 2008 out of my dorm room, honestly, and in 2013 I fell into 3D printing, and honestly I changed the entire business to revolve around that, but it's not really revolving around 3D printing, it's revolving around new age technologies that can enhance X. And that's how I describe it when I describe what I do, in a sense, for a living with my team, my very, very talented team for that matter. going in, back actually real quick, our ecosystem that we created, educate, support, create. We have an education division, it's K through 12. Support is what we do on professional services to companies like General Motors, Lockheed Martin. We actually have service contracts with them and architecture firms, you name it. Create is our area where we have our products. We actually have our own 3D printer right here that we actually manufacture ourselves on the other side of town. We provide this to right now about 10 schools in Jersey City, and we've made about 100 of them at this point. Is that about right? We're getting to that point at this point. So it gives you more backstory. Next slide. These are areas of curriculum that we focus on in order to educate people on these elements. These all correlate to what I'm getting into and how they impact industries. But we teach kids as young as 5 years old how this can impact the world and what they could do in their future. Moving forward. Now, again, backstory there with education. So we can move past that since I've given you the backstory there. It's things like energy. Our partners over in Italy, they're making large scale, about that big, of that printer right there, that scale of a wind turbine. Or like say a vertical one that you would see on a roof ventilator on top of a roof. But they're making it with 3D printing. And when in the end, I'll get into why they're doing that. But that's just a brief overview of that. Going into the next, food. Hydroponics, aquaponics systems, 3D printing them, cost effective, using upcycling, using materials that you can find locally, and then you grow your food in the same way. So you have this ecosystem that you create and you can live off of. It's a new way of living. When I get into the last slide here, you're going to understand how this all connects and that the future is greener. No pun intended there. Moving on. Medical. That's something that we hit really hard right now, and that is blowing up right now. But with Jersey City Public Schools for the past 3 years, we've been doing biomedical engineering. First year we started off with just simple 3D printing prosthetics. The next year we added in biotics, so we taught them computer programming on the basic level. We gave them the code, but one of them actually rewrote it, and they were a 4th grader. Very impressive. This year we're doing sound visualization. We're teaching them about the ears and actually the harmful effects of loud music, that it doesn't regenerate. But these are basic things, but you have 3D printed hearing implants, things like that. But hospitals will be doing this in a new wage, and it cuts their costs by X. I don't want to say because I don't really know those numbers precisely. Moving on to the next, art. I'll be very brief because we're going to be going into clay, and then one of the people that we've worked with, Gene here, Kegel, he is going to show off his project that went from a traditional format to a new age format. But it's pretty damn cool, right? Furniture. What you're sitting on, no one's ever actually really sat in that, so I'm taking a risk. No, I'm just kidding. We sit in it every day. It looks put it up there.
Somebody's gonna be good.
Yeah, someone's got to do the testing. Product testing 101, right?
We're back. This is actually really
So, and real quick on the 3D printing furniture, we've actually gone to High Point Market. Is everyone familiar with High Point Market, North Carolina? Yeah. The 3D printing industry is changing that industry big time. One of our clients, Eugene's been working with, they're trying to now take it and go from going to Vietnam, Thailand, and bring manufacturing here. So again, cutting the time and also making things unique and one-of-a-kinds. That's really kind of the summary of what's going on in that industry. Now we get into, back to that, sorry, the home. That's where this all gets tied together. Our partners, Wasp over in Italy, I go there a couple times a year. I hang out in this beautiful house is where I stay. No, I'm just kidding. But I could, in relative. That's on their campus they've now created. They're actually going to be creating a village, and we're trying to hopefully eventually replicate that here, but no promises.
I'm sorry. Is that 3D printed?
That is 3D printed using natural surroundings. That's using the soil and whatnot and using elements in order to make it happen. They claim a zero carbon element, they claim a zero cost because you're upcycling, right? They do use some wood and whatnot, but very low amounts, or sorry, small amounts for that matter, and they put it together. But it's mud, right? So it's a mud house. It's very old, way back in the century. They had it done right? What do we do? We changed things and made it expensive. But they're trying to do this and then tie all those other elements together. So in the end, we build a 3D printed, say, village, which could be a little school, educational campus, right? But you can live off it. You create the hydroponics, you create the energy that way, so you have power to it, etc., etc. And now you put it all together in an ecosystem, And not only are you now disrupting all these different industries at the same time, you're creating this massive ecosystem that is going to change the future for all of us. And that's why they say they're WASP. Let me explain that further. Their acronym, World Advanced Saving Project. They're actually a project, not really a company. They just create printers in order to fund their end goal. All right, last slide. My little saying about this. 3D printing and other 21st century technologies are a solution for small, so I put it small businesses in bringing their big ideas to life. And that is why our vision and mission statement is materializing imaginations. Because again, if you have an idea, but you think it's too costly to put together and make it come to life, no, there is a way. Where there is a will, there is a way. So that is my presentation tonight, and now I'm going to pass the mic, but I'll leave it for a minute or two to Q&A. Okay, thank you. Does anyone have any questions? Uh-oh, Mr. Candidates.
Yeah, I was going to say.
We've already applied to that market as well, by the way.
Well, I was going to say hemp. Is hemp being used as a active
We've done and actually brought products to life in the cannabis market. So, but it is something that is very applicable to that market as well. Actually, in the sense of, I believe, correct me on this, but hemp, no? So, we'll leave it there. For next mark, or next time.
For next month.
Okay, let me structure my question. Are you using hemp to print?
So from what I understand, and I'm not an expert in it by any means, but from the regulation standpoint of what they're doing, that's what they will be doing. So, yeah, construction materials, that is going to be the most disruptive in this industry, in this market for that matter. The construction market will blow up in this in many different ways. Right now it's kind of at a holding point, at a holding pattern for that matter, but it will release and then it's just going to blow up.
I saw a video online of some vegans 3D printed a steak.
Well, I need to meet these vegans.
You need to meet them.
There we go. Can I trademark that? Sure.
It's just a quick one. So they 3D printed using mud?
They're using the natural soils, and they're actually using it's a salt compound,
Yeah, they're
right?
basically taking the earth from around them, getting hay, combining it together so it has some kind of structure to it, and then they're using that as the base material to 3D print it in the end, so that way it has some structure that holds it together and some installation features to it with having the hay and whatnot into it, and then they add the roof and whatnot to it in the end. So they currently have a contract with Dubai that they're going to be working with them to make low-income housing over the next 5-10 years.
The goal is by 2020, but I believe it's been moved to 2023, is to have 80% of new houses built 3D print. And that's what they're working on.
So, I mean, you just listed a whole bunch of projects that you guys are working on. Like, where do you see the company in like 5 years? Do you plan on narrowing your focus, or do you kind of just
Our focus is
education?
And what it is that we're not doing all this. What we're doing is empowering people by taking them through that process. So that's what our skills is. When it comes down to it, we educate kids and we create curriculum and helping them understand how to use this tool to enhance X. But our real goal as Pico Solutions is what we do, is we act as the service and maintenance provider for these printers. They come to us asking, should we do this? Can we do this? We know. We've been through it. We're surrounded by all these different clients that are doing X, Y, and Z. So we're able to actually, in a sense, consult them and tell them, don't even bother, because it's not there yet. We have a client, as an example, using one of our printers, trying to do something that we fair warn them that it's not there yet.
So I guess this is a two-part question that's purely based on your opinion. Purely based on your opinion.
Sure.
What would you say is the most profitable market, and at the same time, second part, the most influential market in terms of if you went towards education, if you went towards construction, if you went towards biotech?
So I'll start with the second one. Influential is always education. The younger you can get them and plant the seed, the better. To answer that one straight to the point. Profit, that's a mix. With my background, I have degrees in business, marketing, accounting, and finance, right? Bottom line, microeconomics, macroeconomics. You want to get into those nitty gritty, let's go to the data scientist, first and foremost. But the bottom line is, you got to understand wants and needs, and then your price and demand. Those curvatures, you need to look at all of them with a fine-tooth comb, figure that out. But it also all depends. One of my employees' favorite phrases, because it will. In the cannabis market, honestly, I could say that getting it to market quickly and then going there, I think is a good market.
I'll think about fixing the potholes in Jersey City with this little robot that just flies around. Now
you got a hybrid of things, right? You got a robot, and yeah, 3D print, whatever.
So what do you think would most benefit in terms of the next 5 years? What sector do you think would benefit the most in the next 5 years?
Next 5 years, if I were to answer that as quickly as possible, so I'm giving you the most truth, that's the way I gauge it, I'd say medical.
Yeah?
To be truthful. Yeah. Medical is one of the most costly things in the world, right? Well, mostly in the US for that matter. I mean, my wife's from Shanghai, I go there, $20 bill, $2,000 here. Bottom line, medical is definitely being impacted heavily. On a cast or a prosthesis, you know, a prosthetic that was $10,000 is now $200. So you want to talk about profit margin? That's like a shirt now, where it costs $1 and you sell it for $100, right? Come on, like these are the things that are happening. Now, hopefully, people don't, further to your question and piggyback on it, is that they don't take advantage of that. Because if we're going to bring these costs down, as a businessman myself for many years, pass that on to the consumer. So that's going to be the question. It's going to be on the morals and ethics of the business people in that sense. Bringing down costs, do you keep your same price? So that's really the question on their plate, right?
That's fair.
All's in their court.
Yeah.
Any other questions? Want to move on to Greg. Thank you so much.
Thank you so much. Good for Mike. I'm not going to say too much. He'll explain everything to you, but I just want to introduce my former Stevens classmate, Greg. He's working on this awesome startup that's helping reduce carbon emissions in landfills, and he's incorporating 3D printing into all of this. So without further ado, Greg Schrin. I'll kind of just, you tell me when.
Perfect. All right. Well, thanks for having me. It's pretty cool to be up here, pretty cool to be in the space. As Ben mentioned, we work with landfills. I wouldn't say we're directly in the 3D printing industry, but we use it very frequently, and I think it provides us with a competitive advantage. Essentially, we develop IoT products that enable landfills to harvest more methane from garbage as it breaks down, which means the more methane they can harvest, the more energy they can produce from that gas, but also less methane going into the atmosphere. So I'm going to talk a little bit about the problem we're solving and then get into some more technical stuff related to 3D printing. But in this country, over half of our waste ends up in a landfill. It sits for a little while, the organics break down to produce methane. Landfills are required to collect this gas so it doesn't go into the atmosphere. The problem is right now that the way that gas wells are tuned is incredibly inefficient. So a technician has to actually travel to hundreds of gas wells at one landfill, tune them by hand. It's really time consuming. It would almost be like trying to control the temperature in this room by just turning the thermostat on or off maybe once or twice per day. It would either be way too hot or way too cold. And that's what happens with the landfill. You either under-collect this methane, which means it goes into the atmosphere, or you over-collect it, which means you pull ambient air into this really valuable gas stream, which decreases the value and makes it really hard to burn and destroy effectively. Some other information. So in the worldwide, landfills release about 800 million tons of CO2 equivalent, which is roughly equal to the annual emissions from 174 million passenger vehicles. So it really is a huge problem, not just financially, because all of that represents lost revenue opportunity, but in terms of climate change, methane is really, really potent, and it's really, really bad in terms of heat trapping potential. And even if we divert all waste from landfills, waste that's already buried will continue producing methane for at least the next century. So even if diversion is completely successful, the problem will still exist, but diversion is proving to be quite challenging. And also, if any questions pop up, just raise your hand.
This is a serious question.
Sure.
Where do cows stand between the landfill methane and the car methane? Where are the cows?
Cows, agriculture is number one. Landfills are third in terms of top methane emitters, yeah.
Oh, wow.
10% of the world. Yeah. Yeah, it's a big problem. Cars don't technically release methane. I think number two is, like natural gas drill rigs and that sort of thing, inefficiencies in the transporting processes. Yep. Okay, kind of hit on that a little bit. In general, landfills only collect about 75% of this gas, so 25% just goes into the atmosphere.
Are there any things that, outside of capturing the methane and getting it in its purest form and burning it, are there any other uses for it that people are currently developing?
So the big market right now is, so landfill gas is about half methane and half CO2. So removing the CO2, so you basically have 100% natural gas, and then using it as a transportation fuel. There's a lot of renewable energy credits for that. So the market is booming. There's a lot of outside capital going into the waste industry. That's the biggest one. I've heard liquefying it and using it as like a diesel substitute, biodiesel. Some people are working on that. But right now it's generally burnt for electricity. It's a lot of technical jargon. Get into the 3D printing stuff, I promise. So this is one of our devices. As I said, a landfill typically have 200 gas wells, so each gas well will require a device like this. Instead of sending somebody to manually tune each gas well with a handheld device, we have all the sensors built right in and a valve actuator. So instead of once a month, you can tune each gas well every hour. So it really just makes sure that every gas well is collecting as much of this methane all of the time. And in this picture, it's on the next slide too, that enclosure in the second image is actually 3D printed. So we start with a 3D model. When we prototype, we 3D print the entire enclosures. Or we actually outsource this one because we don't have a printer that can print clear. But then we actually take that 3D print, pour a silicone around it, and then form a soft tool, almost like injection molding, so we can make much better quality parts and we can make them much more quickly. So to walk you through this, the gray part in the top left is actually a 3D print that we hand finished. So we sanded it, we wet sanded it, got the surface as smooth as possible. All those little sticks on it, we just hand glued, they're bent, so when you fill the mold, air can escape. Glued them on, poured silicone over that, so that formed the two-part mold, which you can see in the middle there. The left side is the upper part, and the bottom cavity is the lower part. When we fill it, we stick a bunch of straws in it, and then we basically just pump resin. So from the 3D print, we're able to make this mold that we can produce much better quality parts, and we can produce one part about every 4 hours, so it's much quicker instead of waiting a day or two for the 3D print. And in the middle, on the bottom, is actually the finished product, so we have a clear part.
Sorry, I just had an idea. Had you tried vacuum forming?
So vacuum forming would work for this part of the enclosure, but the white part has it has some more structural components on the inside and ribbing and things like that, where I'm not sure it would work. But it's something that we've looked into and kind of opted out of it. It would be much easier. Yeah. And this is really good for us. We're a bootstrap startup, so being able to develop new technology very, very quickly and inexpensively is incredibly important. So we can actually develop an enclosure, we can 3D print it, and we can test it all within a couple of days, which is very, very huge because we have a small engineering team, not a lot of people looking over designs before we actually test them, so we make a lot of mistakes, and being able to see a mistake physically and then correct it in the CAD software and reprint it is really invaluable for us. Also, by using the casting, we can get really high quality beta prototypes that we're able to really give out to customers. We have 5 devices right now installed in the field, and they're working really well, great quality. We didn't have to invest in $30,000 worth of tooling to really get to market. So we actually started generating revenue per each device on a monthly basis without having to pull the trigger on the real hard tooling. And then just some really cool examples where I think 3D printing is going in terms of industrial 3D printing and the industrial 3D printing revolution. So Relativity, I'm not sure if anyone's heard of them, but they're a company that's 3D printing rocket engines. They're able to take the part count down from a typical rocket engine from 3,000 parts to only 3. So that includes the nozzle and the chamber, which huge cost savings, about 80% over traditional manufacturing methods. They could print these rocket engines in a matter of days versus machining them and assembling them over a period of months. So far, they've been around for about 14 months. They've built an engine, designed an engine, and already test fired it over 100 times, which is pretty unheard of in the aerospace industry. And then GE, they 3D print one of their fuel tips for their jet engine. So again, they reduce part count from 20 parts to 1 part, which means 0 assembly. So it eliminates all assembly error. You're not having somebody sitting there with a screwdriver putting 20 parts together. Maybe they don't torque a screw down correctly, and then that screw comes out and destroys the jet engine in flight. significant cost savings, weight savings, which translates to fuel savings, reduced carbon emissions. So it really has a big impact on the industrial 3D printing industry. And that's all I have. Thank you.
You said that 25% of the methane in ordinary landfill just evaporates into the atmosphere.
Yep.
Have you collected data on your prototype or on your project that suggests that you capture more?
So on a small scale, we've seen a 22% increase in BTU flow. We need to work back now to compare that to actual surface emissions. So that means taking another instrument and measuring surface methane emissions, parts per million. But I'm hesitant to make any performance claim because just because we've seen a 22% increase on one gas well doesn't mean, it could mean we're pulling that gas from another adjacent well. So trying to really balance the whole system and collect the whole surface. So once we have more units out, we're expecting around the 20% increase, I think.
It's still early days, but
exactly. It looks promising.
I was curious about your, I think I read an article about GE or saw an article about GE kind of reinventing themselves in the printing space. Their stock has kind of been in the dumps the past, God knows how long. What's your take on GE and whether or not 3D printing is going to revitalize that company? I don't know if you know the answer to that or not.
I'm not sure if it's going to revitalize the company. I think there are plenty of really viable applications in the aerospace industry for 3D printing, especially with a lot of the metal printing. I'm sure we'll learn more about that later, but I don't know if that's enough to help GE. What's bringing them down? Are there outside competitors?
Well, they just really haven't pivoted quickly enough with some of the other competition in the past 15 years.
I think electrification of the aerospace industry is going to be really interesting. I mean, we're far away, but.
So in outside countries, they're generally, first world countries, a lot better about recycling and have separate trash bins everywhere, as opposed to in the US. The cost of your system, as opposed to the cost of educating the average US consumer, do you have any idea where it lies?
We haven't looked into the cost of educating the average consumer, but the recycling and diversion rates for the past 10 years have basically been stagnant. So the market doesn't want it, especially even with China's recycling ban. A lot of recycling now is even ending up in a landfill because there's no market for it domestically yet. It's kind of in shambles. It's a big shit show in the recycling industry. But you're right, yeah, abroad. I mean, landfilling happens a lot less in more developed countries in Europe. Eastern Europe has a pretty big landfill market, but it's an interesting thought. I think the best thing to do is look at the waste disposal system as a carbon balance equation, kind of like a heat loss equation in physics, and you want to minimize the heat produced or the carbon produced. And I don't think it's a set answer for every country or every place. But any other questions?
Any other questions?
So let's say ideally I invested let's say $1 million into the company. Where do you think they would allocate those funds to progress it further to make a greater change? Would it be in just specifically a greater number of quantity products to get more testing, or would it be an advancement, or?
Yeah, probably just growing the market, growing our test fleet right now. I don't think we need $1 million. I think we can do that for probably a couple $100,000. The waste industry isn't particularly eager to adopt new technology, so we're going to have to probably give out a lot of free trials, which gets expensive. But yeah, probably just growing our hardware fleet. And once you have a really large installed hardware fleet, it's kind of hard for people to actually kick you out. Once you get the hardware in, you upsell on the software. But yeah, $1 million would probably just be growing sales and growing our hardware. That's the point. But if you want to give me $1 million, I'll
I think that was an offer, dude. You got a contract. You wrote it up before.
Offer acceptance.
Taxes are high, guys.
All right, everybody give it up for Greg. All right, now we're going to look at a different industry altogether, art. So Oh, we have Gene Kegel, and he is an interdisciplinary artist who has started kind of meddling around with 3D printing, how it can be incorporated into his art. So, thank you, Gene, for being here. And
it's very different from actual real life purpose.
Hey, this is the diversity of Jersey City Tech Meetup. We like to see all different elements of how it's incorporated, or will be.
So that I have. So we can start with the black one.
Black one?
So I've been working with idea of recreating organic reactions as to show the beauty of nature, beauty of things that are happening, kind of for the idea of the people slowing down and taking note of the beautiful nature around us instead of being caught up in other things. Kind of getting away from the politics and social things and everything like that, just kind of as a way to escape or to stay sane. I wanted to work with beeswax, so everything's made with beeswax. And this particular is a mixture of beeswax and graphite. And the series is about very similar to lava, or origins of Earth. And the forms and the shapes that it creates, it's completely, I don't control it, I just let it happen. It's basically a single shot reaction. But the nature of the material is very fragile. So as beautiful as the object looked like, I ran into issues of shipping it or making it larger scale. So, and also I thought it would be really great as a public project to have somewhere as a sculpture. So to recreate that, I was looking into the option of doing 3D print, just looking into new technology. So I got the 3D scanner. What was the brand of it? I forgot.
Does Mike know?
Which one is it?
I don't know. Mike disappeared.
Okay. So the 3D scanner is pretty good.
Do you know the name of the 3D scanner it uses?
Should I admit? 3D Systems, the 3D scanner that we use. It was the iScan.
The one that Gene has. We don't know.
Oh, the one you have?
Yeah, the scanner.
Oh, I apologize. I use the
It's pretty nice. It's the name skips my mind, but the interesting thing about the scanner is that for the scanner to recognize the distance to the subject, it needs to look at it with two cameras at the same time, and there's a distance of like looking with two eyes. So if those two cameras meet at a certain point, if there's any sort of barrier, like like you have a lot of cavities in that object. So if the two cameras cannot meet at the same object, it cannot register that surface. So the problem I ran into with this is basically getting all the detail. What I was able to do, actually, what helped me the first time, I accidentally dropped it.
It's part of art.
And so when I picked it up, and since I already had the scan going, and I put another object inside and kept going to scan, the software was able to figure out that this part is a part of the bigger one. So it was able to put in the points that were missing. So from this point on, I started breaking the original objects so I can get as much detail as possible to get more angle. So of course, in that sort of thing, you completely destroy the original, but you get a scan. So from that, actually I have a picture of the scan in there. So the software was kind of, no, there's more of them. Is there like a video I sent or something like that? Do you have a video in there or anything?
That's it, you know that I forwarded up?
Yeah. So before so when you scan it, it basically has a little surface, but afterwards you have to do before, yeah, there you go. So this is the finished scan. So it looks decent on the screen, maybe because of the colors, it looks really nice. But I think it's in it before I create it. No, it already looks like it. So you have to create a single object, because if you don't create a single object, you can't mesh it. You have to mesh it. The word is mesh. So if it's not a single mesh, the 3D printer doesn't know how to process it or doesn't know how to make a 3D model out of it. So I was working with Eugene, trying to figure out how to do it. He was able to simplify, like my knowledge of 3D was very limited. So all I was able to do is I got to this part, which seems like it's actually far enough, but it's a total cheat.
It does feel,
yeah, it's a total cheat. All I was able to do is just get rid of some extra parts. But if you look at this versus the original, you can see it's lacking some of the detail, but it's not as apparent on the scan as it is on the final project. So I actually had Eugene print it with, I think it was Ultimaker, right? When I saw this, so this was made with that machine, I think, Ultimaker 3. And the interesting thing about that machine is that it can print with two different materials. So because of these things as they go up, they need a structure until it cools off and things like that. So the beauty of this machine is the material it's using, what is it called? Dissolvable material. It can dissolve. So after I print it, the structure can be dissolved in the water. So after you wash everything off, you get the actual object. Versus if I would have used a different technology like SLA or resin printing, I would have to go and manually and cut off all the structure and supports, which for something this complicated, this complex, would be almost impossible. Now this is nice. I mean, obviously there's size limitations with this kind of printing, and also details. It basically created a thing of its own. It's very different from the original, but it kind of works. So I think the main sort of what's the word, obstacle that I'm coming across is scanning it, because I'm not able to get all the details. So there's a solution is to scan it with a CT scan, similar as you go to the doctors and you get a full scan. So it's able to almost like X-ray, so you can see all the internal structure. So this way you don't have to, you don't have to break the model or anything like that, and you get a much better scan. So with a much better scan, you can do other stuff. I mean, with technology nowadays, you can print things up to 5 foot, by 5 foot by 5 foot cube out of material, although it might become really heavy, but it depends on the structure inside. So I'm looking into that, and I'm also, the people who I'm trying to print with during the large print for 5 by 5 by 5, they recommended doing 3D carving. So it's basically taking the same file and using like a 9-axis router machine to carve it out. And they can carve it out of wood, they can carve it out of marble, they can carve it out of graphite, things like that. So something that is very fragile, something that's not usable, this technology is allowing me to make something larger scale, so I can enlarge it, and also be able to do some public projects with it. And so my whole idea is to, if this works, then I can start applying for public projects, because I would really love to see this like on a 10-foot sort of scale. Yep.
Is that solid or is it hollow inside?
That's solid. I think.
Yeah, it is.
It feels solid.
Well,
to a degree.
Yeah, so basically with how 3D printing works is that it makes the perimeters to go all the way around, has a top and bottom surface, so it looks solid from the outside, but there's actually like a cross-section pattern on the middle that's actually filling it. So it's not like if you cut it in half that it's entirely solid, but it's solid enough, especially for what he's doing.
You get to choose the internal.
It's got a skeleton.
Yeah, it's got a skeleton on the inside.
Can you change that direction of where that gap is?
Yeah, you can make adjustments in the software to be able to adjust it.
If you want that print to take forever, yeah, absolutely.
I was just thinking construction like
What resolution was that printed in?
For regular.
That was printed at 0.2 millimeters layer height, or 200 microns.
That took
72 hours.
72 hours, yeah. That's it.
So how much do you plan on going, like 3D printing and like new routes of art versus your old methods? Like how much do you see yourself shifting to that versus kind of traditional methods that you've been using?
So like I said, I'm stuck at a CT scanning. So if I could get a reliable scan that I know I can produce a result that is somewhat resembling of the original, that would be useful. Right now, it's almost like creating its own thing. which is not bad, but it's also unpredictable a little bit. Also the cost of that. So the amount of hours it takes, like that, things like that, it may not be as feasible to outsource it. So I might actually have to be buying a machine like that and doing more learning curve, things like that.
She can go first if she wants.
What kind of scanner did you use, and did you ever consider using LiDAR to get a sense of detail?
What's a LiDAR?
It's a kind of camera that it collects light from all directions off the surface of an object. It's kind of like sonar using light, but it might be a way to get a representation of that object. And so I'm wondering if what you're using is better, because I was on a different project and I want to talk to you afterwards.
Yeah, you can talk to both of us after. I mean, he did all the research on the scanning. We were really just there doing consulting to make sure it was possible to print.
So I can double check. Just give me 1 second, I'll tell you what.
Yeah, I'm actually about to
the
piggyback
same thing as
also.
volumetric scanning.
Okay, sure. Yeah, volumetric scanning.
Well, the volumetric scanning, but also, what was your cost on your scanner?
So it wasn't.
If I may ask.
So there were two options. The one, I think it's called EinScan. That's it, EinScan. So there was, I bought 3 scanners just to test them. I got the SP Plus, EP Plus, Pro, EP, and SP, which is a desktop. So the EP or EP Plus, it's something that has rapid scan, something that's handheld, and you can do a large area and it shoots, but you lose on resolution. So it's much faster. You can walk around, it'll get the information, but you lose the resolution. So I found that the desktop, so like something like that would be like $6,000 to $8,000 for the handheld with rapid scan. If you don't want a rapid scan, you don't mind taking longer time, you're talking about like $5,000. It's actually better resolution, just takes a little bit longer. So there might be advantage to that. But the desktop, which is the cheapest, which was like $2,000 or $1,800, was actually higher resolution than the handheld one because it was static. And it came with a turntable, so the turntable automatically would turn the object. And I actually added another additional sort of a bonus pack, it's called Discovery Pack. So it added additional 2 infrared cameras on top of the regular ones or something like that. And it would allow me to have color information. So by having the color information, it would give me a better resolution, better detail of any sort of things. So I had that. However, at the last scan, so it wasn't really where I was getting like all kind of jittery stuff. So I'm like, forget it, I'm returning it. So as I was returning it, I realized that one of the lenses was actually screwed not as tight. So I think that was causing some of the issues. So in terms of something that is something you could put in a turntable, something that's not bigger than maybe 8 inches in diameter, I think that's a really good solution. For the larger stuff, you have to go to that. They made some new one now. But EinScan, I think, is probably the leading one in terms of what you can buy that's affordable and pretty usable, except the software is really terrible. So that's where I ran into issues. So the hardware is good, but the software, even though I upgraded the computer, the camera, everything else, it was so rudimentary that, because like for something like this has a lot of detail, I had to take, and I broke it apart and scan, like it had like over 2 million points or something like that. I don't know what I call them. So it couldn't handle it just because it wasn't, I didn't know how to utilize the system. So it would crash on me after like hours and hours and hours and hours of work. So it was also limiting on the resolution. So it's a combination of scanning and processing, then I would be able to get better results from printing, because printing is really the last step. So it's the in-between.
Well, one more question.
So I guess another 2-part question.
Johnny, 2 parts.
I'm trying to combine them. I'm trying to come back to $1 million. I'm scared. So first part. So in what way would you see the 3D printing impacting the art industry in general? And in second part, what way would you see that impacting in an ideally 5-year term where like if something worked out and it really impacted you in the way you would like?
So I think you know, durability and scale and cost and also amount of people involved, it would narrow down. So before, for a public project, you know, they have a certain budget of limit or things like that, or even a really high budget, I think it will open the doors to a lot of younger artists who are able to do the same thing for like 1/10 of a cost or less. Because, you know, if you're talking about making something like this out of bronze, I think I was quoted 500,000 maybe. Ooh. For like a 10 foot by 10 foot.
And if you could change one thing to make it ideal in the next 5 years, what would that one thing be? Like, what would be the first thing you adjusted?
In the art world or in the printing?
Let's go with printing.
Okay.
Art world fast.
So I think printing something that would be a finished material right away, a finished product, that would be ideal. So now how they're doing printing with metal, printing with like SLA, like instead of using the SLS methods, it's kind of like it's using lasers or something to harden the material as it goes up. So you have a much better detail, and it's completely smooth and structural. So if they're able to do that, because right now, like the only machines I've seen, they're like 5 by 5 by 5 inches. So it's a limitation of that. So if they have something like that on a larger scale, I think if they figured out how to do that, they would solve a lot of the issues. But then again, you know, you got weight of the material, durability of the material. But yeah, if you can print something that would not require for a human to go in afterwards and sand it or print it or prime it and have to go through all the stuff, so it doesn't give you the raw object but a final print, that would be ideal, I think, in any industry.
All right, everyone. All right, quick.
Just on that question, because I'm also an artist, but I do digital based.
Right.
So, kind of like just like an alternate perspective, I guess. On
Piggyback
the question. It's for me like I can like create toys, right, just based off of art, and now I don't have to wait for like manufacturers or, you know, people to actually make the things. I can just like go and print it, right? But, you know, based in like having a little foundation of finance, I can paint my own stuff. Like I don't have to, but like, you know, just to be more involved, like I can paint my own stuff. But I can have.
Is there a question?
No, it wasn't a question. It was just a answer a question from an alternate perspective.
Cool.
But it changes kind of like if you are an artist and you want to sell stuff, or if you want to like create more stuff, it changes like the dynamic of like.
If I may summarize it in the sense, entry to market.
New media. Exactly.
It's entry to market.
It's
That's
new
all that.
oil and canvas.
You know,
I mean, it allows more people to create something. Like for something large, it usually requires a lot of money and finances. So
Yeah, barrier to entry is always an issue with any industry.
yeah. So if you can cut down the cost of producing something and have the same scale, I think it opens up a lot of potential for public works and things like that, which is important.
All right, perfect. Thank you guys. Thanks for Gene. We'll give it for Gene. I'm gonna let Mike introduce Eugene because they work so closely together.
And we'll be in touch, right? Sure. You have your print, right? Make sure you don't forget that.
Absolutely.
So I'm going to introduce one of my guys, Eugene, who is the basically technical side of everything. But at the same time, I already can tell based on body language, he wants to introduce himself. Now, Eugene is a very talented designer. He came into the company actually in university and point blank just took the role and ran with it. And now he's been working with all our clients. He actually takes care of all of our what I call pro services, basically Pico solutions, and works with our bigger clients like General Motors, etc. But what Eugene's going to hit the topic of is actually piggybacking off of Gene. Eugene is going to piggyback off of Gene. Anyways, he worked with you, Gene, on the project, but he's actually going to now open up your eyes to the area, which I reference most of the time when I'm talking to clients as low density materials, but he's going to fixate on something much more simple in the sense of clay. And that is something that is evolving, and in my opinion, I'll leave it here, is that it is the fastest growing area of the market right now in the education space, and will be the professional space. Eugene, take it from there.
Okay. First, if I could get a raise of hands of who understands how a 3D printer functions or works. Okay, all right. I will very quickly go over just exactly how most plastic-based 3D printers work, and then we'll transition over to how clay 3D printers work. So, 3D printers are basically a robotic hot glue gun. So this is the glue, this is the plastic that you're printing with. Inside this machine there is a motor which takes this material and pushes it into a heating element. That heating element heats up that plastic, lays down essentially a single strand of the material, and then builds up and up and up. So if you look at any of the 3D printed objects, especially like looking at the chair, you can see there's those layers on it. So that's because it makes that single layer, raises itself up, and goes up and up and up from there. So we're going to be focusing on clay 3D printing. It's something that's really emerging as of right now in a huge market that we're tackling. You can go to the next slide. So first, I'm going to show a quick little video on exactly how clay 3D printing works. So you should just be able to click on it and then maximize it. So WASP is the company, these 3D printers that we manufacture, well, in the process of manufacturing. The sound isn't important. So let me
pretty cool though, come on.
Let me go a little bit slower.
Some good sound. I'm digging it.
You can see this is the clay 3D printed object. You can see all those layers on it. So this system uses the plastic, and there's a motor that's pushing it. How the clay system works is that since it's not a continuous strand, you have to have something that's pushing all the clay into the container where you're going to be loading it, and then there has to be a motor that's granularly controlling it so it comes out and you can control the flow rate of it. So what this is doing is, you can see it's making a pass around that one section and then it moves to the next. This another one is just another art piece, but you can see all those layers that it's making in the end, as well as some of the pieces of art that are made on there. Something big with the ceramic, and I'll get more into it a little bit later, but is with the art that since with ceramics you're able to put a glaze on it which will remove the majority of the layers that are seen on there, that will help mitigate the problem that Gene was having, in the sense that you can remove those layers that are on there. So you're going to have to 3D print it and put a glaze on it in the end, but it's going to be much more of a final product as opposed to taking a plastic object and trying to sand and finish it in the end. So this is them just taking the raw material, it gets loaded into this canister. From there, the canister is mounted onto the machine, air pressure pushes it through a tube, and then it goes into the small little black extruder right there, which has a motor which is controlling the flow of material in the end. From there, it's just extruding it out, keeps building up and up. That's a time lapse of the print in the end, and you're able to make your final product. This is also showing the larger scale machine that allows you to do much more rapid prints, because you can essentially with these just take the plate that it's printing on top of, remove it, or in this case moving the actual machine, and keeps repeating the process in the end. So this is able to make certain geometries that would be next to impossible to be able to make by hand, as well as, let me go back to that just so I could show you. So with something like this, you could see one half on the left-hand side is the actual 3D printed shape, and then on the right-hand side is after they did some kind of surface finishing to make it the appearance that they were looking. So this removes a barrier of entry into working with clay or ceramics, in the sense that, you know, you're not going to be able to have someone just getting into ceramics or do a weekend class of them making something, obviously not that scale, but with that amount of detail. But what you can do, and some programs that WASP has run, is that they 3D print these on a miniature scale. You give them to someone, you say, this is what you're working with, you're going to clean up the layers, make it your own, and be able to make a final product that you could be proud of in the end without having to have all the time of learning to work with the clay, being able to make those forms, and all the detail that goes along with that. So that's just demonstrating that you can physically move that machine and just keep printing out more objects. And WASP works, in a large degree in the art industry on some of the different items that can be made in the end. So we can go back to the PowerPoint and go to the next slide.
Can I ask you?
Yes.
So obviously it's different materials that we use for products. Does the configuration setup vary in the elements that go into the actual tubes that pump this stuff in? Vary based on the texture and the actual material?
Yeah, so in terms of working with plastic versus working with ceramics, the workflow of it is essentially the same, except there's a few more things that you have to configure, like the consistency of the clay, how dry or wet it is when loading into the machine is going to change how much material you have to push out in the end, because working with ceramics or working with clay is an exact science. So you have to keep that into account when working with this machine, as opposed to with plastic, these are the exact properties of this is exactly how it's going to work, and you go with it from there.
Higher maintenance period in terms of higher maintenance and cleaning and stuff? Yeah,
you're going to have to say, if you have the material loaded in there for a week, it's going to dry out to the extent that the air compressor may not be able to push the clay into the reservoir for it to extrude in the end. So there is a shorter lifetime that the clay actually has inside of the machine. Yes?
Big back in again. 3D printers use the plastic and use heat. The clay use heat, or you said air compressors?
The clay does not use any heat. All that it's doing is it has an air compressor which pushes the clay into a small reservoir to make sure there's always clay loaded into that reservoir, and then there's a motor that controls it and pushes it out in the end. So one of the main advantages and one of the biggest reasons that universities are getting this machine are for material science. So when you're working with plastics in 3D printing, there's 4 or 5 main plastics that people end up using in the end, as opposed to when working with clay or ceramics. Universities have whole departments dedicated to this and working in this, in which they can do their own research experimentation on the material. And as long as you can load it into that canister and you can push it through into that little reservoir, you can print with it. So we have universities that are buying the machine that, say, the civil engineering department, that they're not actually interested in 3D printing at all. They're interested in testing their materials, so they may just be using the 3D printer to make a structure that they could test the strength, the weight, and all those different things in it. And the 3D printer is the medium that allows them to do that testing they were never able to do before. The other thing that you had touched upon about the heating is that it has faster print times because there's nothing to actually heat. And the material that's coming out of it is the layers are so much thicker that you could have much faster print times than previously. Yes?
Piggybacking on his question, what is the level of effort involved in cleaning it out in between like material testing?
Or if you don't?
Well, if you don't clean it out, then it doesn't work.
Exactly.
Right, but what's the level of effort involved?
Yeah, it's definitely more than you do with plastic 3D printing. So I would say after you run through the material, normally with plastic-based 3D printing, it would be, 5 minutes to be able to swap over to the next material. With clay, and if you have to clean out the whole system because everything dried out, I would say maybe half an hour. So it is significantly more than you have to do with plastic, but you're also doing very different things than you'd be doing with a plastic-based 3D printer.
If I may add to it, obviously our experience together here, but plastic at times will, say, melt around the extruder and you'll spend hours actually cleaning it up. The amount of issues that occur with clay printing in that manner, where you have to clean up those, is very rare in comparison, but you should really clean up your mess after you're done, to say the least, in order to avoid having that downtime.
Yeah, the problems, I'll get to your question in a second. The problems that occur between them are different. This is more a matter of you have to understand the science of the material that's actually being used. And once you understand that and master working with clay, so if you have, you know, a department that works with it 24/7, they know the consistency that it needs to be able to extrude or, you know, work with the clay, as opposed to plastics. It's predefined. You don't have to worry about that. So up front, it's more because you have to understand the basics of how working with clay and what entails with that. But in terms of the actual operation of the machine, I would say it's less than working with plastics because there's really less that can go wrong once you have the material correct. And yes, what
you have to bake the clay in a kiln after?
That's going to depend on the clay that you're using. Most clays, yes, and there's slightly different process you're going to have to use. Mainly because with 3D printing, there could be air bubbles that occur. So if you make an entirely solid object, if it's hollow when using a kiln, there's a chance of basically exploding in the kiln. So you're going to have to make sure that you heat the chamber up gradually with the part inside of it, so that way, you know, it doesn't explode. Yes.
So let's say you have an already plastic form. You have a 3D printer. Is it a small adjustment to have it use clay as a medium? Or do you need a whole new machine? Do you need, what is the transition between the two?
So we have certain universities, like Harvard, had just bought the extruder from us. So the system for extruding the material, you know, the clay, the canister that goes with it, and they had their own 3D printers already that they just mounted it on and used it. We have the design files for the extruder available online, so if they, you know, wanted to mount it on their existing 3D printer, they just take our 3D model, mount it onto their machine, do some testing, and they can go from there. So it is possible to go into a different machine. There's a little bit of work that's going to go into making sure it can mount properly and it's stable enough and the printer is actually strong enough, but it's definitely possible, and a lot of schools and universities are doing that. Yes?
Speaking of like different materials, I keep hearing everybody talk about hard materials. Are you able to 3D print in like a soft material, like a rubber or something more like a phone case or something soft?
That's a little bit outside the scope of the clay, but that's definitely possible. There are plastic-based materials called like TPU, like the one he just threw at you. Oh. There are softer materials that you can print with. The constraints of the material have to be a little bit finer, because if it's a rigid plastic, then it's easy for a motor to just push down. But if it's, you know, flexible, if it's not properly constrained, then it may just kink out to the side or something of that sort. So there's other complexities come with that, but yes, you could definitely do flexible materials as well.
Cool.
Okay. I kind of got into a medium that people are familiar with. Like I was saying, you know, there's a lot of people that work with clay and use it already. So taking it and being able to make things that they were making before, but say at a larger scale, because they could have every single version be exactly the same, is something new that they could do, as well as lowering the barrier of entry. Like I was saying, with students taking, you know, existing model that has those layers, cleaning it up and really making it their own, and then being able to put it in a kiln and fire it in the end is something new that you were never able to do before. Okay, so the different applications for it is we have Carnegie Mellon. Their architecture department had purchased the machine from us. The large one that we have over there, slightly older version, that they were doing basically, I don't know what the best way to describe it, just interesting like shapes and designs that would be artwork on, like on a wall or something like that for an architectural feature that they were using it. For art, University of Michigan, or Michigan State University, I forget which one, had recently purchased the machine. They're using it, doing research into different materials that could be used with it from there. Civil engineering, I think it's University of California, that they're doing the material science. They're purchasing the machine just to test materials, and they really don't care about 3D printing at all, which is something that's interesting. And then lastly, aerospace. So what I'm saying with the ceramic materials is that there's a lot more flexibility that you have with it, because you just need the material soft enough that it could just be pushed into the reservoir and extruded in the end. As opposed to with plastics, you know, there's 4 or 5 that you're going to be using. You can do so much more experimentation. One of the clients that I'm working with is, you know, he has his own patented material that he had used for 3D printing homes a couple of years ago, and now he's adapting it to using it on our machines. And he has that certain material patented that it's fireproof, hurricane-proof, everything, every kind of regulation you can imagine, it has gotten through. So he's in the process of using our machine to be able to turn that into reality. But he partners with aerospace companies that are taking these machines, and ceramics is particularly good for those for high temperature situations, that doing something out of plastics obviously wouldn't be good, or even metal sometimes. So ceramics has a lot more applications in the aerospace industry than a plastic-based 3D printer. We'll go to the next slide. Okay, and then the last thing is that printing with clay or ceramics really brings back something that it's, you know, still prevalent, but is not something that, say, a new and upcoming engineer would want to get into. So, you know, if you think traditionally working with clay is not new technology, it's not what's up and coming, and if you know, put yourself into there, that may make it so you don't have opportunities other places in the future. The same client that I was talking about before previously is in the process of getting about a dozen of these machines from us to get them in local universities in California. So that way, not only are you working with the ceramics, working with clay, but you're also working with 3D printing, the new technology that comes around with it, and you're able to work in this medium while still being up to date with everything that's going on in the world, with understanding how to do the 3D modeling, how to work with 3D printers, and really doing workforce development for people in the future. So that concludes everything I have about the clay 3D printing. If you guys have any other questions, feel free to ask.
We're gonna hold those last questions till the end, because we still have one more speaker. Just looking at time, we're gonna move on, and then any questions we can talk to Eugene after or at the end. Thank you so much, Eugene. We need you like 20 All right, I just for our last speaker, I'd like to introduce Dave McPhee. He is the director of 3D printer sales for SimQuest. I'm gonna let him explain what SimQuest is, because I'm sure I'll ruin it somehow. So I will pass the torch to Dave.
You guys bought the beer, so that's so does that have a USB? Do you have a USB port on that? It's a back. I don't know how that.
We have your thing on.
Yeah, so I'm just trying to figure out. I can move faster if I use this, or if you're going to be my Vanna.
Oh yeah, I mean, if we could.
Can you use this? No.
Will it work with a Mac?
I don't know. Find out. Find out right now.
If not, I'll always be your Vanna.
If not,
I'm like a really good Vanna.
Hacking into my, not like hacking into my system.
What's that?
He's identifying.
Downloading everything as we speak right now. So
saving all of your data.
Get all the data. Get all the data. Get all the data.
Not Japanese. All right, let's see if it works.
All right. See.
I'm your Vanna.
No,
I am your Vanna.
You're the Vanna. All right, so good enough. Right, I'll take it back. So, all right. So as Ben said, my name is Dave McPhee. I'm the director of 3D printer sales. I have 40 slides. Got a lot of pictures, so I'm going to move fast because I figured 10 minutes.
Do you want us to tap this?
Yeah, that's good. That's good. Okay. So I've been doing this for about 20 years. I'm a mechanical engineer by trade. I'm a salesperson by necessity. That's because I make more money as a salesperson. My wife is she's become accustomed to a particular lifestyle. Okay? So my agenda, I want to give you an intro to SimQuest. I'm going to talk a little bit about 3D printing, additive manufacturing, kind of the difference, or at least what it means to me. Okay. I'm going to dispel some myths about 3D printing, some applications, the benefits for 3D printing, give you a little taste of what's next, and then obviously we'll jump into the Q&A. Okay. This works too. So a little bit about us. We're a 28-year-old startup company, okay? Been in business since 1990. So about a third of our company are engineers, a third of our company are machinists, okay? We've been selling a product called Mastercam for 28 years, which is CNC programming, okay? So we know a lot. Our DNA is in manufacturing, so we get it, right? So we understand about metal cutting, okay? So like I said, a third engineers, a third machinists, and then the other third in the company basically kind of keeps us from killing each other. So we've been doing 3D printing for about 20 years. We rep a particular vendor, Stratasys. We were with them for about 17 years. I still wish they were part of our portfolio. Okay, good products, made good money. My wife was very happy with the paychecks. But the thing that we learned on our 20-year journey is that there is no perfect 3D printer. Okay. So a lot of times when we talk with companies, you'll see that there's different applications, okay? So with Stratasys, they only had kind of 2 technologies, and also as a reseller, you can only sell what they have. So we felt that there's a lot of emerging technologies. I mean, the technology is not new. It's actually been around for about 30 years. We're still scratching the surface, okay? I would say the patents that have been issued in the last 5 years dwarf what's been out there for 30 years. We wanted to be part of it. We felt that our customers and our prospects wanted to be part of it too. So we made a change. We ripped out all the wires about 1.5 years ago. We fired these guys. We replaced them with 6 different vendors, okay?
They bought MakerBot.
What's that?
Stratasys bought MakerBot?
Yeah.
No one wants to talk about that.
Yeah, they did. Enough said about that, right? Additive manufacturing, 3D printing, okay? Left side of my brain, right side of the brain, right? So when I talk about 3D printing, I think about conceptual models, fast, easy, inexpensive. When I think about additive manufacturing, I'm talking about end-use parts. It may not be cheap, but there's a lot of value, okay? I'll use both terms interchangeably. People will go, what are you talking about, right? Because we like to use those words, additive versus 3D printing, right? Because they're really cool. When I started, the phrase 3D printing, yeah, you're not going to be able to read that. Don't even try. Okay? Don't even try. Just back up. Okay? So what's the bottom line here? What I'm trying to point out is that if you boil it down, there's actually 7 different technologies or 7 different processes for 3D printing. Okay? From those 7 different, they kind of spider web out. Each has maybe a different take on it, right? But there's a lot. Okay? There's a lot here, right? I mean, obviously, some of the stuff that I've heard tonight, what I've covered, I've seen a lot of the extrusion-based stuff. I've heard SLA, I've heard DLP. Okay, there's a ton of it. Now, the thing to be concerned of, what I've learned, okay, you have to be careful. This is a double-edged sword. If you get blinded by the technology, right? So I'd say there's 2 ways here. Number one is that there's companies that say, holy shit, additive manufacturing, 3D printing, what do I do, right? I don't, if there's a good return on investment, you have a good business case, fantastic. On the flip side, there's people who want to 3D print just because it's fascinating. It's what I call the F word, okay? Fascinating. That kills me, okay? Just because you can print it doesn't mean that you should, okay? Bottom line, right? So you want to definitely have kind of a good balance of looking at something and saying, okay, is there a good application for this, right? Is the technology perfect? Someone said it, I think it was you, Eugene. Greg was giving his presentation, right? Did I get it right?
Got it.
Excellent, okay. 3 beers, I start screwing up names, right? So you were asking about, hey, what about thermoforming,
yep.
Right? That's perfect. That's exactly what should be happening. You should be challenging these things and saying, is 3D printing the right application, or is it injection molding? Is it casting? Is it wood pattern making? Whatever it is, every part has a spreadsheet, and you've got to look at it, right? Just because you can 3D print it doesn't mean you should. Okay. So some of the past, what I call the hyped up myths, right? Every person's going to have a 3D printer in their home so that they can basically build parts from a digital catalog. Okay, who here has heard that before? Right? Okay. You know what? Durability, low cost, surface finish, color, you name it. Right? There's a lot of things that you need to do. Now, is it possible that you might be able to get that? But this was part of the bubble, right? That probably burst about 4 years ago. What I call the hype. Okay. The other one is additive manufacturing is basically going to replace traditional manufacturing. Okay, that's another bullshit myth too. Am I allowed to say that?
Yeah, absolutely.
Okay.
Can you double down on that?
Right. Right. So, if you go into a typical CNC machine shop, right? They have mills, they have lathes, they have wire EDMs, right? These machines all have a specific purpose. Okay. 3D printer is just another part of the process. Is just something in the tool chest, right? I mean, I'll get a little bit about the dynamics about maybe how that might change in the future, but basically 3D printing is it's another tool, right? You have to be careful, right? If I remember I learned this at a very young age, right? I'm looking out my kitchen window. My father sees the neighbor working under the hood of his car with a hammer. Okay, I will not tell you what my father said when he looked at it, right? But the thing is that when your tool is a hammer, the problem is that everything looks like a nail, right? Right? Applications served. right? 3D printing is going to fit in one of 4 buckets. Everything, right? Conceptual models, functional prototypes, manufacturing tools, end-use parts. Anything we do in that space is going to fit in those 4 buckets, right? I'm trying to figure out how the hell does clay fit into this home building. Hey, that's an end-use part. Okay. By the way, huge military application for that process right there. DOD, Marines, you name it. They're looking at the technology to say, okay, when we basically land the troops on some island someplace, we want to be able to use indigenous materials to build shelters for our people without having to transport that stuff thousands and thousands of miles. So that's a huge application, right? Again, I'm totally about the ROI, right? Actually, my wife is really more about the ROI in this stuff than anything else.
Yeah, she received her ROI.
Yeah, there's a difference, big difference, right? I drive a Volkswagen, she drives a Hemi, okay?
So she has.
What's that?
So she has received.
She has received, right? So 3D printing, right? So what can we do? Go back to the fascinating. I thought you would appreciate this with the little skull, right? Yeah. Hey, it's all about doing the neat stuff. Hey, right? You know, absolutely. You know what? I can do lots of neat stuff with 3D printing. Okay. And I can do lots of fun stuff, right? You know, to toys and hey, my grandkid wants to have one of those, or my kid wants to have one of those, or you have the, you know, the figurines. And yes, I am one of those people that had myself 3D scanned and created it as a figurine. Okay? And my engineer Tom, okay, every time he wants to test out a new printer and he's looking for something color, he reproduces me. So everyone who comes to the office thinks I'm an asshole. Multiple images of me, and then I learned in Kuwait, if you make an image of yourself, if you make a 3D replica of yourself, it means that your soul has departed you. And I have like 20 of these things around the office, so I have no soul whatsoever. Okay? Right? But let's talk about, when I talk about those 4 buckets, talk about conceptual modeling, right? Getting the point across, right? 3D printing's not new, it's been around for 30 years, right? So I'm just trying to convey a concept, okay? We can communicate so much with a 3D model, right? Absolutely, right? So we convey, how do we communicate? We use words, we use pictures, we use images. This is just something else, right? So yeah, all right, I can make food, I can do food, stuff like that, okay? There's my hammer, right? Package design, right? Companies like Nike, okay, DeWalt, you name it, right? So before they go, when they want to market something and they want to get buy-in from their staff or from their customers or whatever and say, hey, this is what the end product's going to look like. I can give it to you and you can play with it and feel with it, okay? That's huge, right? So that's what I talk about, conceptual modeling, okay? Architecture, okay? Another great use case right here, okay? GIS modeling, okay? This is actually a paper-based process right here for this, right? As an engineer, I'm not excited about paper. As a sales guy, I'm very excited about POs, especially when it comes from Department of Defense. They love topographical maps, okay? Not sure what they use them for. I'm sure it's probably not good for somebody else, but they do a lot of it, okay? Some cool applications, right? You know, maybe it's the Smithsonian, right? And they have dinosaur bones that they don't want people to be able to touch, right? So they'll 3D scan and they'll replicate these things so that they can actually preserve the actual artifact, okay? Movie props, okay? Stop motion photography, okay? Medical's huge. I mean, you kind of touched on it, Michael, before you were talking about like prosthetics and, you know, let's say customized insoles and stuff like that. But pre-surgical planning, probably some of the coolest stuff that I've done is taking data from MRI or 3D scans, 3D printing so the surgeon can figure out, okay, this person has cancer in a very difficult spot to operate on. They'll 3D scan the organs, okay? They'll basically they'll 3D print, and then the surgeon will try to figure out, okay, what's the best way for us to attack this through surgery? Let's practice before we actually cut the patient open, okay? I've been involved in several of those. It's the coolest thing when they come in and say, we tried 6 times. The first 5 times we would have killed the patient. The 6th time we actually got it right. So it's good to know that they're practicing on that stuff before they get there. So that's absolutely huge, right? And I love to point that out because every time I talk to someone, they go, what do you do? I sell 3D printers. They go, do you make guns, right? Because that's right. And you've rolled your eyes, exactly, right? You've heard that before, right? But they don't, but that's because what the newspapers sell, but this is the stuff that people don't know about, okay?
Real impacts, right?
Exactly. Prototype applications, right? I just have one slide here. So this is more about material properties, right? This is more about testing. Okay, maybe it's chemical resistance, maybe it's heat deflection, maybe it's just a flexible part, maybe it's clear. You know, that's a material property, okay? So now what I want to do is, before I build my part, I actually want to do some kind of physical testing. I'm going to injection mold, but I have to have some relative idea that this thing's going to work first before I do that, okay? It's more about kind of taking those models and beating it up. Maybe it's form and function, or stress tests, or wind tunnel tests, or whatever, okay? But then we get into manufacturing tools, okay? Huge, 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 huge appetite. I thought, like, you know, okay, the engineers are cool, right? Design engineers cool, R&D, that's where the money is. I was so wrong. And I was so wrong because I didn't realize that manufacturing has so much more discrete money than R&D does, right? R&D budgets get cut all the time. But if you're in a manufacturing plant and your product doesn't get from point A to point B, regardless of what they say their budget is, there's magic money that appears, okay? If we can't get this from one side of the shop out the other side of the shop to get it to the customer, regardless of what the budget is. I hear it all the time, you know, design engineering, oh yeah, we got to cut back and we can't spend money on that new project, or we can't do this. You go to manufacturing and you say, how are we going to get this out the door? All of a sudden, there's just this magic money, right? So, you know, jigs, assembly guides, right? Work holding fixtures, okay? Huge appetite for 3D printing, right? Anyone that's doing, you know, what's the Six Sigma, right? Okay, where everything has to be in its place, okay? This is another perfect application for stuff like this, okay? Molding, okay? I've actually got one piece over there if you guys want to take a look at it, right? So, you know, rather than...
That's row?
Yeah, the green part. Yep, green part, right? So that's a temporary injection mold. You put something like that in a mud frame, that's not going to hold up. Yeah, you just pass it around. That's not going to hold up the same as something that's machined out of like a hardened steel, okay? But maybe I can get 50 pieces out of that. All right, so as a medical company, and I need to basically test something in a very specific plastic, and I've got a setup for that, I can 3D print a mold and then be on my way, okay? Casting applications, okay? You name it, right? So investment casting, you know, sand casting, right? Pattern making, right? Patterns is a science, okay? That's almost I shouldn't science, really more of an art form for someone to make a pattern. Usually it takes about, let's say if I'm doing sand casting, it takes about 8 to 14 weeks to actually make a pattern just to get that part. So if I'm going to a foundry to say, here's what I want to do, I can actually 3D print a pattern in a matter of days and go through that process. I'll go a step further, okay? There's some metal parts over there too, Eugene, okay? Those are metal printed. That's a process that is, that's desktop metal. And I'm using an FDM style 3D printer to create a MIM part, and then I'm putting it in the furnace and make all those parts are 17.4. I can have those in my hands in a matter of 2 or 3 days, okay? So I can actually, depending on how much money I want to spend, right? I can use a relatively cheap printer to make a pattern, or I can invest a couple $100,000 and actually just go right to making the part that's going to replace the casting altogether, okay? Forming. Thermoforming applications, right? Same thing here, right? So thermoforming, metal forming, you can do hydroforming. We're doing stampings, okay? If the material is hard enough, right? Probably not going to do it with a material like a PLA, which is kind of weak, but a lot of these printers can do stronger materials like ABS, polycarbonate, Ultem, you name it, right? So the harder materials I can actually do on limited stampings. No, I have one of my customers in Hartford uses a $20,000 printer and creates dies for stamping. And I've been trying to sell this guy a $100,000 printer for like 5 years, okay? I mean, he bought the $20,000 printer and I'm grateful, but it's time for him to spend more, you know? And I'm like, hey, we can, you know, this bigger build size, harder material, what a great application. And when I talked to him, he was like, yeah, hey, I got 600 shots out of that, and I crushed the part. And I'm like, great, it's time for harder material, $100,000. And he goes, I'll just print another one. And then I'll run that one for another $600,000. And I realized this guy's never going to buy, right? Because that's all he needs, right? That's all he needs. End of arm tooling, right? Robotics is huge in assembly, okay? You know, how these things, you know, pick and place, assembly, so forth. If I can minimize weight and the end application, what we call the end effector that picks up that part, if I can lighten the load on that, okay? The great thing here about end of arm tooling is I can incorporate a lot of things. I can put in vacuum lines. I can have parts that are hollow on the inside, so they're not machine, you know, metal. Maybe I don't need as big of a motor on my robot, okay? I can also respond a lot faster. Someone comes to me and says, hey, I need you to do this and add the, you know what, I can 3D print it. I don't have to wait weeks for someone to actually develop this stuff. So this is huge applications, okay? So now we get into some of the cooler stuff, right? Rocket nozzles, right? Actually, I think Greg kind of mentioned some of the stuff. I have a few of the same slides that he does, okay? There it is, right? So the fuel nozzle for the GE LEAP engine, okay? Yes, absolutely, right? So 20 parts that were all boiled down, I believe, to 3 parts. Now this was in development for a long time. This wasn't an overnight thing, right? GE did not want to be the company that was producing the fuel nozzles for the jet engine for the plane that ran out of fuel or clogged up over the Atlantic and everybody went down, okay? So this stuff has been tested upon tested upon tested, but everyone knows about it because it's very visible, but there's a lot other stories that are not as visible, okay? But this is a great one, okay? You know, Airbus appetite for 3D printing in both aerospace and medical is huge, absolutely huge, okay? But there's also plenty of examples, maybe not as sexy as metal, in plastics. Again, if they have a good return on investment, okay, you name it. There's too many to count. Again, not as sexy as Airbus or SpaceX or the GE nozzle, but plenty of applications where plastic. In fact, there's probably more applications for plastic than there is for metal. It's just not as sexy. Okay. Additive manufacturing sweet spot for end-use parts. It's a combination of two things, right? It's your quantity versus your complexity. If your complexity is high and your quantity is low, that's a great fit. That's a sweet spot for additive manufacturing, okay? What we tell people is we say complexity comes from free, okay? But as your numbers grow, again, I go back to what I said before, every part has a spreadsheet, okay? If I'm going to make 1 million of something, okay, let's say I have a small gear that fits in the palm of my hand, and I'm gonna make a couple of million of those, probably injection mold is gonna be the right application to do that, okay? But if I come back and say, I don't need 1 million, but I only need 10,000 or 20,000, well, now the problem is that I can't, it's cost prohibitive, right? I can't afford the tooling cost to do something like that. But, you know, that's where 3D printing's just getting to in the last 3 years, okay? Some of the benefits with 3D printing, right? I can create parts that I wouldn't be able to manufacture any other way, right? So we say there's really no limitations, right? So I'll expand on that a little bit. You know, some great aspects, you know, fluid control, right? Manifolds. If you look at the part on the left, which is kind of a traditional manifold, and I have to drill, to my knowledge, no one has invented a curved drill yet, okay? It's all straight drill, so I have to sit there and drill. What's that?
No, we came across something in Ada that was kind of weird. Not yet.
Yeah, maybe, who knows? Maybe, right? But, and then you look at the part on the right, you know what I'm able to incorporate is I'm able to manufacture something that I would not be able to produce traditionally, okay? But keep in mind, so the whole machining aspect doesn't go away. When we're doing this in metal or even plastic, a lot of times we look at these things as what we call near net shape, meaning that I still have to do the surface machining. I still have to machine critical areas, bearing surfaces, and so forth. So we're not going to get away from that, okay? Not yet, okay? But I can take advantage of these things, right? So other great applications, thermal management, okay? You look at the parts on the left, those are using like heat sinks. You know, we're putting in fins so that we can cool naturally, right? On the right-hand side, we're pumping fluid through something, okay? Conformal cooling. This is huge in injection molding, right? So again, going back to that, you don't have a curved drill yet. If you look at the part on the left-hand side, that's typically how we would do something. We would drill, we would cross drill, and then we would basically cap things off to try to build a circuit, okay? Where the part on the right, I can actually 3D print where I have conformal cooling so that my cooling channel is always a certain distance from the surface of my mold. What does this mean? This basically means that I can get better parts out of my injection mold. It means I can also reduce my cycle time. Okay, reduce my cycle time, increase my yield, it's more money. More money makes everybody happy. The part consolidation, there's the GE fuel nozzle again, but then I'll talk about the part on the bottom, okay? So one of the printers that I sell, HP, there's an air duct that they use, right? That air duct as designed was 7 different pieces that were injection molded and then assembled together, right? Think about it, 7 pieces, each one means a different tool, okay? Now what I can do is I can build something like that. I can create the part as one piece, that I don't have to build all those separate pieces, right? So everything there, so everything, that part on the left-hand side was 3D printed as one component versus 7 different components on the right-hand side. So now I get to take advantage of the technology. So, and I don't have a picture of this, but in the one printer that we sell, on one unit, 60 pieces on that printer are fabricated through 3D printing, and on another printer, 140 pieces are fabricated using that technology, right? So they're basically using that at some scale, right? They get to a certain point, they start selling a lot more. Guess what? They're gonna move to injection molding when it's financially viable for them, when it makes sense to do that. But right now, the quantity, some of these printers are in the hundreds of thousands of dollars. So we're not selling these things by thousands upon thousands a year, right? You know, I think HP is happy if they sell a couple hundred units a year. So they're nowhere near, you know, the injection mold type quantities, okay? Talk about weight reduction, right? So if you look at the part on the left, if you can see that, versus the part on the right, the part on the left is 3D printed, right? So both of them are just slightly less than a kilogram worth of material, but you look at the material waste, right? So on the left-hand side, I'm using just over a kilogram of powder, and I'm machining away maybe a third of the kilogram, okay? On the right-hand side, I'm starting with a block that's closer to 5 kilogram block, and I'm eliminating 75% of that through machining, which is also a lot of energy, a lot of wasted time, okay? And I also can't create a part that's going to be as complex, okay? Final part design. So here's another great example. This is an HP, but this is not a 3D printer. This is something off of one of their 2D printers, okay? It's a bracket to hold a spectrometer, okay? And the way that it was originally done is it was machined. It was machined aluminum in 3 pieces. Pretty simple geometry, right? There's nothing really complex about that part on the left, right? Aluminum is pretty easy to machine. 3 different pieces, bolted together, bada bing, right? So someone said, hey, wait a minute, you know what? We actually sell these things called 3D printers. Maybe we can use that to kind of redesign it. So they went out and said, hey, you know what? Here's a great thing. We can now produce that in one part. We can do lighter, it's lighter weight, we could do it faster. And then someone said, you know what? We can go another step, okay? Another step was, do we really need all of the surface area? Do we really need all of this mass, okay? You know, what can we do to try to do some weight minimization, right? So basically what they did was they reduced the weight by 30%, but ultimately the big story is that they actually reduced the cost by 85%. Now what you don't see on this slide, and Eugene, if you do me a favor, you'll see 2 parts right next to you. You see, nope, yep, hold on here. Yep, you're warm, and there's a second part. You're burning up. Perfect. Yep, you have your hand on it right there. Okay. So you'll see the one in his right hand. That is your right hand. Yes, sir, it is. Okay. In his right hand is the final part on this slide. something I'll touch on later, if you look at the part on the left-hand side, it's the same part, but this was done through design optimization. So if you could pass those around, you'll see it kind of looks like, it looks more alien structure, or like you're looking at bird bones, okay? This is where we're going in the industry, okay? But that wasn't captured on this slide, so that meant even more weight savings, even more cost savings, okay? And I'll touch on that when I get to the end, okay? Another benefit, what we call re-engineering the supply chain, okay? The LEAP nozzle, the jet fuel nozzle that we talked about. The one thing that wasn't on that slide was that some of these components, so these were 30 different components, right? Some of them traveled the world 3 times to get from point A to point B, right? So during their process, where it was manufactured, go to here to be post-processed, go to here to be heat treated, go back here to be welded and so forth. And that was the thing. Again, some of these components literally traveled over. Think about all the energy and the costs in moving those parts, right? So now what you have, and this is where companies like GE and Ford, BMW, all of the automotive guys, right? All of the aerospace guys are looking at the technology to say, what if we put 3D printers in distribution hubs, right? Like today you have, like on the 3D printing, right, you have like UPS jumped into the game a couple of years ago, right? So UPS kind of is a service bureau because where they have their planes in Louisville, Kentucky, they have 3D printing shops at the end of the tarmac where they can 3D print, load stuff on the planes, and then fly it out, right? So they're basically trying to kind of cut down on the time it takes to get that. But, you know, here's a company like Ford that's looking at it saying, hey, rather than us creating these parts, and there's minimum quantity inventories that I have to worry about, okay? And then I've got to build that. I've got to issue a PO. Then I have to take all these parts and I have to stock them. And I have to put them on my shelf. Then I have to pay for the warehousing for all those parts that I have to buy at the minimum, which is huge dollars. But what if I go kind of real minimalistic and I have just enough parts to kind of get me through for X amount of time? But at each of my distribution centers, I have these 3D printers. And then when I know, all I have to do is just basically send. And in that one 3D printer, I can print multiple parts at the same time, okay? And now you think about, how does that work with tariffs? And then we're shipping parts back and forth, right? So the shipping costs, the cost of all that stuff, right? That's where they're trying to get to, okay? What's that? Jump to the Q&A? Okay. All right, so I'll tell you what, I talked about the design optimization. This is the last slide, and then I'll just kind of jump to there. Design optimization. This is where the industry's going. They're going to use software to basically, so the part that's being passed around, right? We're going to use software to basically optimize the design. Okay. Yeah, that was pretty much it. The rest of it was just kind of an attempt at humor. So we don't.
You can bring that into the Q&A.
So. Okay, so he had his hand up first, and then I'll go with you, sir. So,
I guess my main question, the only question I have is, what's going to happen? What do you think is going to happen when everybody has a 3D printer and can make this stuff?
Not everyone's going to be able to afford some of the stuff I'm selling. Okay, so it's right. So when you say everyone has a 3D printer, it's relative. Okay, so
I'm not going to have a 3D printer.
What's that?
I've known about 3D printing for a long time, but I just got involved in it. But my printer was only $300.
Yeah, no. So everyone can have a 3D printer. It's going to be a lot on product development and what is it going to look like. Okay, so let me try to put it in perspective this way: the 3D printing market, the rapid prototyping market, is about $8 billion, okay? The manufacturing market is about $14 trillion, okay? So if everyone has a 3D printer, they're gonna play in that $8 billion space, okay? It's on the high end, the manufacturing side, that $14 trillion, that's where, but there's a different scale. You're talking $300 to $300,000 to millions of dollars. right? So economically, it's not feasible for everyone to have a printer, okay, like that.
I was wondering, 3D printing and patenting, is there an issue? Does it go together? What happens?
3D printing and
patenting.
And patenting.
Is it, for example,
Well, there was a guy that was here before, probably could have answered that question better than me, right?
That's Jimmy right now?
Was that? Yeah. I don't know if I have a good answer, so I don't know if I even want to try to answer that one, okay?
I mean, you show an aluminum part on the slide before, right? It has been 3D printed into another kind of, another design. Who is old?
Is your question?
What about the owner of the patent of the initial?
Is your question more about the patenting of 3D printing technology or the end product that gets made in the end? So the intellectual property that you generate with the machine or the technology on the machine itself?
No, the patenting of what you generate with the machine.
Oh, yeah.
I mean, you see the end product.
Well, basically, I can print somebody else's idea.
Yes.
What you're saying.
What does it?
That's another law altogether.
Yeah, that's a whole nother tech fest right there. Yeah. Yeah, I don't think I have a good answer for you, so I really don't want to try. Okay.
It's not really changing it. It's if you create something, you can patent, right? As long as you don't publicly announce it, right? That's the one law behind everything when it comes to patents. So,
yeah,
but if you're bringing someone else's stuff and stealing it, you're stealing.
The only thing I'll say about that is that there is definitely a focus in the industry to make sure that the parts that are being produced are legitimate, okay? That it's not someone just kind of jumping in the game and saying, hey, I have a metal 3D printer that I put in my garage and I'm going to produce parts for aerospace industry because I have the money and I can invest in $1 million printer and put it in my garage and basically build parts for Boeing that no one's going to know about, right? So they are trying to figure out a way where they can kind of regulate and track that stuff, okay? There is no good answer for that. It's not exactly kind of the patent, but you're kind of talking about, hey, how do we make sure that the stuff is legitimate and it's not just produced on whatever, right? So there's a bunch of different ways. Some companies are trying to use functional inks. They're trying to put markers in the material.
They're trying to do actually crypto.
Right. Yeah.
They're trying to actually interconnect crypto to actually have some trackability. One of the companies that Gene and I had worked with, they honestly failed at it. But the bottom line is they were trying to. It's not crypto actually. Sorry. Block. Thank you very much, everybody. That was a major mistake there. But blockchain is what's going to be able to control that.
Yeah, you have one company that basically says, hey, we can print a barcode on the part, and we can do that. The problem is that if I have a sander, I can go over and basically remove your barcode off the part, and you don't know that. But then there's other things that they can do with inks or materials or things that they can embed inside of the material that is that's markable.
Yeah.
So
not in terms of the actual physical product, but I've seen certain things that you have the 3D digital file that you make in the end, the STL file. There are things that people have basically made a software that you take that model that you have, put it through their software, and it basically puts a digital imprint inside that model that you made. So you're not going to be able to tell with the physical object, but if, say, someone was saying, this is my file, you'd be able to put it through that software and says, this has my digital footprint on it, and I'm protected from it.
Oh, that's cool.
It's like a watermark.
Yeah, essentially, but it's invisible.
Small scale watermark.
Yeah, I'm sure it's removable to some extent, but generally, it's still new and up and coming, so, it's fighting to see what happens.
yeah, we're a long ways away from that, so, yes.
Yeah, because there's that story about the $2 million screw, right?
What's that?
There's that story about the $2 million screws.
That sounds like it would be a government
paying for like $2 million for a screw.
Yeah.
So, what prevents you from printing a screw and saying $2 million?
I go back to what I said before. Just because you print it doesn't mean you should. Okay, absolutely. You had another question.
I retract my question.
You retract your question.
Let's do one more question, Miles.
All right, so I got to look at
You get one part and then Mike gets the last question.
He does make me nervous. So
one parter and then Mike's last question.
Okay, hypothetical.
So I'm just throwing out random. Actually, all this talking got me thinking like 20 different ways, so I'm gonna try and refocus this. let's say I lived in a third world country and I built my own 3D printer in some way. Would you find it more proactive to try and disrupt an industry in some way and try to directly improve what they have in terms of what I've seen from you, or would you go with more of an innovate and try and create approach and try to create a new kind of a new process? I don't know if that makes sense. Let me know if that translated right. I know that was hard to throwing it at you, bro.
All right. So when you talk about disruptive, okay. If we don't challenge the status quo, we die. Bottom line, right? We fail, right? We have to basically, we have to be able to look at something and let's say I'm going to put it back to you in my way, because I don't know if I completely understand the question, but let's say I develop a product, okay, and I'm very successful at selling my product to the market, okay. The worst thing I can do would be to get fat, dumb, and happy. I mean, I am, okay. But the worst thing for me to do would be just to kind of rest on that and say, okay, I'm good. What I have to be working on is now try to figure out how do I kill my product, okay? Because someone else will. If I don't, they will, okay? So I don't know if that
sort of answered it.
It sort of answers where you're going.
I think I was kind of targeting the salesman mindset that I believe you can kind of wrap around, is that it's we tend to create to kind of implant in what's already there, or tend to create to innovate. So it's so more of a 3D printing can kind of go in the grand creative, like right brain innovate, or left brain like this is already there. How can I disrupt it?
I'm the least creative person I know when it comes to that. So, but the thing is that I see the talent around me, the customers, the people that create things, and they come from all sorts and shapes. Okay. It doesn't necessarily have to be someone with a PhD. It could be someone that's working in the basement that figured out a way to solve something, okay, and make a better mousetrap, okay, and that's what improving processes is what this is about. It's not, and quite frankly, it's really not just about from that aspect. I really wouldn't even throw it at 3D printing. 3D printing is just a tool to get there, right? It's a much bigger ecosystem. Okay. You figured out what your question was?
We're wrapping.
Yeah, we gotta wrap.
Well, we gotta wrap up. It's you gotta respect the space here. We've been here for a while.
Thank you. Do you mind if I ask one question?
Yeah, it's his space. He has to ask.
So, as I explained on my presentation here, right, this is final product, right? This was my initial. I was going through, and the one thing, part of my background accounting, managerial accounting, cost benefit analysis, right? Break-even analysis. Two things that you hit on in every angle. When you're going through that with your client, my question comes to this, right? For me, I did that cost benefit analysis. I said, I'd be an idiot. Point blank, it would cost me 10x to do this, and my clients would be waiting, 6 months to get their product versus manufacturing it, cost benefit analysis there. But where do you think the moral compass is right now? Where is it going with all these, there's thousands of 3D printing companies. Do you think they actually, in this sense, further to your question about everybody having a printer, do they have this moral compass? Because I honestly pride myself with my own company and my team that if it's not a fit for them,
right,
we're not selling to them.
Yeah.
Because one, we believe in the long-term relationship versus short-term. But my point is that I feel that over the past couple of years, the moral compass of the industry has shifted to become less moral. Would you agree, and would you think the future of 3D printing the impact of that is going to have on the 3D printing industry?
The morality of 3D printing.
The morality, the moral compass.
All right, so you know what? It's about integrity. It has nothing to do about technology. And integrity means that you do the right thing even when nobody's looking.
With the impact of all the others not doing that,
so,
what do you think?
You know what? That was one of the reasons. Okay, so one of the reasons why we made a shift away from one vendor versus multiple is because with one vendor we felt we were box salespeople, that we were trying to sell people. We were trying to get them to fit within the solution that we had to offer.
And that's all
okay, we were box salespeople. Okay. Now, because we rep, and we don't have, just because we rep for 6 different companies still doesn't mean that we have it all, okay? It's a lot more difficult, it's a lot more consultative, it's holistic conversations, okay? What we try to do is, if it's not the right fit, and we try to tell people, you know, it's a difficult one, right? Because we want to tell people, if we don't have the solution for them, even if it's the competitor, they should go there. Because maybe we might lose an opportunity over that, but we believe that there will be greater payback on the other side, because we'll win their trust, and they'll come back and they'll say, hey, we have other applications, do you have something like this, right? But I don't know if it's necessarily sometimes integrity as it's emotional. And we, as salespeople, we kind of get hung up on something.
Social emotional learning element.
Yeah.
Yes.
We have after party at Brightside. All extra conversations can continue there. Thank you. What are you gonna ask him after?